Okay, good morning, ladies and gentlemen. First of all, I would like to thank the organization to give me the opportunity to give a talk here. Well, just following Professor Kato's macroscopic view on the urban rail network, well, I would like to go further to talk about the some microscopic study on how we design or how we model people moving in metro station or similar setting. Well, first of all, why we need to study pedestrian flow in modern metro stations? Well, of course, nowadays we have a complex we have complex mass transit system integrating with multi-usage building and campus setting in our built environment. And certainly it is a challenge for the architect, engineers, and other facility manager or some other people involving in the design and management of this complex setting. Well, some people tell me it is not necessary to study people moving around because some stations or some cities only got a few people. But this may not be the story in Japan, Hong Kong, China, or many Asian cities. Well, you can see there is, well, perhaps I can, okay. So perhaps I can show you some information about how congested in the metro stations in Hong Kong, China, or many Asian cities. Well, you can see, well, this is the real case, okay? Every day, okay? In Beijing, this is the situation, how people getting to a train and go for work. So when you see this video, then you understand why we need to study how people moving around. Well, as Professor Kato just mentioned, in Tokyo, the subway system each day handle 8.8 million people. But I think in Beijing, they are handling over 10 million per day. So this is the situation we are facing. While in Hong Kong, of course, it's a smaller city because smaller number, lesser number of stations, but we still need to handle over 4 million people per day. So, so that's why every day we face this situation. And in fact, while in Hong Kong, we developed the metro system for over 30 years. And in the old days, of course, not many people using the metro system, but today we are handling many people and many stations actually designed it not to the capacity to be handled today. So that's why the metro company is eager to how to improve upgrading the system, upgrading the station so as to can handle more people. But the problem is in many urban area, we don't have the land to extend or expand the metro station. So what we just need to do is how we can consider the layout, improving the layout so as to handle the huge number of passengers. Of course, they are getting more lines to divert the tour, the passengers, but meanwhile, they need to consider how to improve the system. So that's why we, over the years, we collaborate with the Hong Kong Metro Company to study how people moving around in metro stations. Okay, well, to study the passenger movement pattern, of course, our objective is to facilitate planning, design, and management for the stations. But how we involve in the in the project, basically we help the metro company to evaluate and assist the planning of the stations by, of course, developing computer models for the simulations and collect field data to provide the insights and, of course, for model calibration and validation. Well, first, to develop the computer model, which I am going to introduce today, the first step, of course, we have to collect the data. Well, of course, we supported by the metro companies, certainly they provide us basically most of the CCTV records, the videos, and we also send, actually we sent over 100 students over the years to collect the information by observation, by counting somewhere, and of course, one very difficult thing to model how people moving around is how they select the route. So that's why we need the students to help us to follow each passengers, how they move around, how they select the route, what route they prefer to go, what stimuli inside the station will affect them. So we basically we collect the information for the passenger characteristics, the passenger walking speed, of course, the path selection pattern, and of course any other activities involved, and some other loading and unloading behavior, gauge pass-through pattern, etc. So we collect a huge volume of data for that over the years. And now from that, we form the database and make use of the data to establish our own simulation model. Well, basically, there's two parts of the simulation model. The first part basically is for the path selection pattern, how the people selecting the path. Well, because we have the data, so and for the human behavior, it is very difficult to model. So that's why we use a simple approach is to establish an ANN model based on the data. And based on that, we establish each path to possibility. And then another part is the microscopic movement modeling. We adopt a so-called agent-based modeling, which can model each individual moving around. And based on a lot of rules to govern how each individual moving around in the system. Well, I'm not going to talk the details about how we model that because it spends a lot of time. But well, we have already published a lot regarding our models in different journal articles. Well, this actually is a simple example how we simulate people moving around. Well, this basically is, is a platform, okay? And the people's waiting for the train at the platform. And another diagram showing the density map boarding and lighting situation. Well, that's actually the density map is a dynamic mapping. So it changes with time. And this actually is a complex stations in Hong Kong. Well, the simulation basically simulate the whole system as a whole. Well, we simulate both the train, how it lighting, unloading, loading, and how people moving in the station and some structures or setting around the stations. So basically, the model will need to handle more than 10,000, 20,000, or 50,000, sometimes, depends on situation, Well, though I'm not going into details for each aspect, but still I would like to highlight some features of the models. Well, basically this shows how each individual moving and the visual region affecting how they move. Well, we based on what we established a so-called utility function situation, how model the individual moving around. And this is some of the modeling, how we model to avoid collision for two individuals. Because sometimes we need to consider how the counterflow or merging of some flows. So each individual, we need to consider how this will need to go. And also for human behavior, sometimes people will be moving in a group, not just one individual. So that's why we also need to consider the group behavior and how they pair the two moving around. And of course, the attractions. There are, well, we basically based on our data collections and know how each, for example, each shop, how each shop attract the people, and any other attraction will affect the movement pattern. So we base on some attractiveness of the attractor, distance, visibility, etc., to model how each individual moving. And of course, we developed the simulation model, but we also need to verify and validate our model. So because we collect the data already, so we build up a database and compare with first the density at each time or the transient situation for the density in a station and compare with our output. And also, we have the indicator on each key points, the throughput for each key point and compare with the output of our model. Well, in addition to that, we also calculate the details of the walking speed for example, the density-velocity relationship for the output of our model and the flow rate for some bottleneck or some key points so as to compare the results with the real situation. And of course, these are some of our simulation for some of the stations in Hong Kong. This actually is several story stations in Hong Kong. And basically, we simulate how people moving around and the density situation. And in fact, we can add the different color for different types of individuals or passengers, and so on the simulation. Well, basically, the model is a 2D model, but for some gimmick, maybe, okay, we also established a 3D animation for the output. Well, but basically, I can say that people walking on the ground is a 2D situation, okay? So only 2D is already sufficient to provide all the key results. 3D is just for some manager or top management to have a look. These are also some other stations we just show part of the station because the whole simulation model is very complex. So we just show part of the simulation. And these two stations is a very large volume pedestrian flow station in Hong Kong. Is an exchange stations with two rail system. Well, to simplify the situation, we show a very simple situation with survey people and how they go to the service counter, go through the gate, getting ticket at the machine, waiting for people. So all this can be simulated in our model. And from the model, we extract the key information for each part. We can measure, we identify the key points we want to have the information and extract the information from the model. Then we can see how each facilities, whether the capacity for each facility is all right or we need some consideration. Well, apart from the normal situation, we simulate the people in the normal situation daily. But we also simulate how people evacuate in case of emergency. Well, basically, this is an evacuation study in one of the deep stations in Hong Kong. Well, actually, this station is located around 18 meters below ground. So that's why they need to use a elevator for the evacuation. So this actually is a notional situation simulating how people using elevator for evacuation. Well, basically, this is presented to the authority to get the approval for this one. Okay, in addition to the simulation, we also, with the help of the metro company, to organize a fire drill exercise in a station. Well, the Hong Kong metro station lines will shut down every day for a few hours. So we organize the drill exercise after the night shutdown at midnight. So in one of the stations, with around 2,000 participants in the study. So we, of course, we structure how the train approach the station and how people moving. And each participant, we provide a RFID tag for them so as to track their position on time. And also, we have some sensor tracking at each park so as to get the data as much as possible. Of course, we also have some video recording and other information. So, so we get the result and compare with our simulation output and see what happened. Well, basically, the results is quite close to what we simulate. And of course, we need to calibrate a little bit for our simulation model. For example, we need to, because well, when people moving around, they need more, they will walk faster. So we need to adjust the movement rate and all other situations in the model. Well, apart from that, we also make use of the model to see how people moving in the urban setting. Well, basically, we have them also to check the location of the station entrance. So where to put the station entrance, where will be the opening. The opening for this one, actually the opening directing towards the street. You'll see a lot of people will cause congestion at this part. But we slightly change the opening position the density will be reduced. So this is basically one of the usage of the model, how we can make sure of it to initially to consider how we detail design the situation. Okay, that's just I want to say today. Okay, thank you very much.